Hello, eco-warriors. Welcome to the very first episode of Green Frequency, your ultimate destination for all things green and groovy. I'm thrilled to kickstart this journey with you all. Before we dive into today's topic, let me just say how grateful I am to have you here. Green Frequency isn't just another show, it's a movement towards a greener, more sustainable future. And you, dear viewers, are the driving force behind it all. Alright, let's get down to business. Today, we're tackling a hot topic that's been buzzing around the ecosphere. The showdown between electric cars and good old-fashioned petrol, gasoline cars. But before we delve into the details, I want to make one thing crystal clear. Green Frequency is committed to bringing you the most up-to-date information on environmental issues. So, consider this our pledge to keep you informed and inspired with each and every episode. Now, let's talk about where it all begins, extraction. Imagine this. Massive rigs drilling into the earth for oil, and giant factories churning out batteries for electric vehicles. But which one's worse for the environment? Alright, folks, let's break down the data on extraction emissions for both petrol and electric vehicles. Here, we have two tables showcasing the energy consumption and carbon emissions associated with extracting the raw materials needed for each type of vehicle. Starting with electric vehicles, on the right side of the screen, we have the breakdown of materials and their respective energy consumption and CO2 emissions during extraction. We've got lithium, cobalt, nickel, manganese, graphite, aluminum, and copper, all essential ingredients for those powerful electric car batteries. Take lithium, for example. It takes 100 kilowatt-hours, kWh, of energy to extract 1 ton of lithium, resulting in just 0.20 kilograms of CO2 emissions per kilogram of lithium extracted. Now, let's compare that to aluminum. It requires 20 kilowatt-hours of energy per ton to extract aluminum, but the emissions are much higher at 16 kilograms of CO2 per kilogram of aluminum. So, while some materials like lithium have relatively low emissions, others like aluminum contribute significantly more to our carbon footprint. Now, shifting our focus to petrol extraction, let's take a look at the numbers. Here, we're looking at the energy consumption and CO2 emissions associated with extracting petrol, the lifeblood of our traditional gasoline-powered vehicles. It takes about 5 kilowatt-hours of energy per liter to extract petrol, resulting in a mere 0.02 kilograms of CO2 emissions per liter. Next stop, logistics. We're talking trucks, trains, and planes ferrying raw materials all over the place. But are these transport emissions a necessary evil? Starting with electric vehicles, on the right side of the screen, we have the breakdown of materials and their respective energy consumption and CO2 emissions during transportation. We've got lithium, cobalt, nickel, manganese, graphite, aluminum, and copper, all critical components for those eco-friendly electric car batteries. Let's take lithium as an example. It requires 5 kilowatt-hours, kWh, of energy per ton to transport lithium, resulting in just 0.05 kilograms of CO2 emissions per kilogram of lithium transported. Now, let's compare that to aluminum. It also requires 5 kilowatt-hours of energy per ton to transport aluminum, but the emissions are significantly higher at 4 kilograms of CO2 per kilogram of aluminum transported. So, while the energy consumption remains consistent across materials, the emissions vary depending on the metal being transported. Now, shifting our focus to petrol transportation, let's examine the numbers. Here, we're looking at the energy consumption and CO2 emissions associated with transporting petrol, the fuel that powers our traditional gasoline-powered vehicles. It takes about 1 kilowatt-hour of energy per liter to transport petrol, resulting in a mere 0.02 kilograms of CO2 emissions per liter. Compared to the materials needed for electric vehicle batteries, petrol transportation seems relatively efficient in terms of both energy consumption and emissions. Hang tight, folks. It's going to be a wild ride. Now, let's get down and dirty with refining and processing. From turning crude oil into gasoline to crafting intricate batteries for electric cars, it's a messy business. Phew. Things are heating up, but we're just getting started. Let's start with electric vehicles. On the right side of the screen, we have the breakdown of materials and their refining emissions. We're talking lithium, cobalt, nickel, manganese, graphite, aluminum, and copper, all crucial components for those powerful electric car batteries. Take cobalt, for example. It requires 100 kilowatt-hours, kWh, of energy per ton to refine cobalt, resulting in 0 kilograms of CO2 emissions per kilogram of cobalt refined. Now, let's compare that to aluminum. It requires 200 kilowatt-hours of energy per ton to refine aluminum, resulting in 10 kilograms of CO2 emissions per kilogram of aluminum refined. So, while some materials like cobalt have relatively low emissions during the refining process, others like aluminum contribute significantly more to our carbon footprint. Now, shifting our focus to petrol refining, let's examine the numbers. Here, we're looking at the energy consumption and CO2 emissions associated with refining petrol, the fuel that powers our traditional gasoline-powered vehicles. It takes about 4 kilowatt-hours of energy per liter to refine petrol, resulting in 0.04 kilograms of CO2 emissions per liter. Compared to the materials needed for electric vehicle batteries, petrol refining seems relatively efficient in terms of both energy consumption and emissions. Fasten your seatbelts, because we're zooming into distribution and consumption. From gas stations on every corner to charging stations popping up like mushrooms, how do these choices impact our planet? Let's start with petrol consumption. On the right side of the screen, we have the breakdown of energy consumption and emissions associated with using petrol in our traditional vehicles. Here, we're looking at the energy consumption and CO2 emissions per liter of petrol used. It's crucial to understand how our everyday actions impact the environment. As you can see, for every liter of petrol consumed, there are approximately 2.3 kilograms of CO2 emissions. This emphasizes the importance of finding sustainable alternatives to petrol to reduce our carbon footprint and combat climate change. Now, let's shift our focus to electric vehicle consumption. While there's no direct consumption of metals like lithium or cobalt, we'll be looking at the energy consumption and emissions associated with using electric vehicle batteries. Here, we're examining the overall impact of electric vehicle batteries during their lifespan. Buckle up, folks. It's time to crunch some numbers. The dreaded math and science segment, where equations come to life. But don't worry, we'll make it fun. Who said math couldn't be entertaining? Strap in, because things are about to get interesting. During the manufacturing process of electric vehicle batteries, it takes approximately 156 kilowatt-hours, kWh, of energy per ton, resulting in 8.06 kilograms of CO2 emissions per kilogram of metal produced. This highlights the significant environmental impact of producing electric vehicle batteries, which contribute to the overall carbon footprint of electric vehicles. Now, shifting our focus to petrol, let's examine the manufacturing emissions associated with producing petrol. Unfortunately, due to the complexity of factors involved in the manufacturing process of petrol, such as extraction, refining, and transportation, it's challenging to provide precise figures for energy consumption and emissions at this stage. However, it's essential to acknowledge that the manufacturing process of petrol also contributes to environmental degradation, albeit in different ways compared to electric vehicles. Now, let's shift gears and talk about the running emissions of both petrol and electric vehicles. Here, we have the data on the energy consumption and carbon emissions during the operation of both petrol and electric vehicles. Let's start with electric vehicles. Electric vehicles are known for their efficiency, requiring only 0.11 kilowatt-hours of energy per kilometer traveled. However, precise figures for CO2 emissions during operation are challenging to provide, as they depend on factors such as the source of electricity used for charging. Nevertheless, electric vehicles generally produce significantly fewer emissions during operation compared to petrol vehicles. Now, shifting our focus to petrol, let's examine the running emissions associated with driving petrol vehicles. Petrol vehicles typically consume around 11 kilowatt-hours of energy per kilometer traveled, resulting in approximately 2.4 kilograms of CO2 emissions per kilometer. And finally, after exploring every nook and cranny of this debate, we've arrived at the moment of truth, the conclusion. Let's recap the data, shall we? According to our findings, the manufacturing emissions of electric vehicles may seem higher than petrol cars at first glance, but when we zoom out and look at the bigger picture, things start to shift. Over the lifetime of a vehicle, which we've estimated to be around 7 to 8 years, and considering an average distance of 200,000 kilometers traveled, a petrol car emits approximately 66 tons of CO2, while an electric car emits only about 10 tons. So, What's the takeaway from all this number crunching? Well, it's clear that while the manufacturing process of electric vehicles may have a higher initial carbon footprint, their lower emissions during operation make them a more environmentally friendly choice in the long run. But hey, don't just take my word for it. I encourage you to dig into the data, ask questions, and draw your own conclusions. After all, every journey towards a greener future starts with a single step. That's all for today, folks. Thanks for joining us on this enlightening adventure. Until next time, stay curious, stay compassionate, and keep making waves of positive change. Peace out.